So folks, this is the way the quiz worked. If this is a 60-degree angle right down here, then this angle right up here has got to be 120 because they're supplementary. So this right here, this angle is 120 degrees. So I'm going to set 2x plus 20 equal to 120. And then I'm going to subtract 20 from both sides. And I get 2x equals 100. And then I divide by 2. And x comes out to be 50. So I did skip over the TS part. I did the x, first because I was thinking about that being supplementary. We discussed that a little bit yesterday, but it came up in some homework problems, and I hope that's clear because they're called same side interior angles. If you had a couple parallel lines and they were cut by a transversal, the ones on the same side of the transversal, this is the transversal right here, and on the interior between the two parallel sides, those are called same side interior angles, and they add up to be 180 degrees total. So that's what I use to find x. Now, to find TS, that's what we did in our experiment yesterday. So we're going to turn that worksheet in. So let's review that real quick. I took some pictures of what a completed worksheet would look like. And, this activity yesterday, I wasn't super happy with how it turned out. Let me kind of show you what we were going for. Is we were trying to figure out that the mid segment is half of the bases added together. That's what we were trying to identify. So when we look at these two bases added together, that gives us this number. Half of this number is the mid segment. The two bases added together is this number. Half of that number, approximately, I know this one maybe has been rounded. Half of this number is the mid segment, right? Half the sum of the bases is the mid segment. So that's what we're saying on that activity. That's what we were trying to conclude, and we added that to our notes, right? So when we look back at our notes, we put that right in here, that half of the bases added together gives us that mid-segment length, right? So let's add a couple things right now since we just kind of talked about this. This angle right here and this angle right here have to be supplementary. So you could say, like over here in your notes, angle B plus angle C have to equal 180 degrees. Now my notation is not perfect here. I probably should have an M in front of the angle symbols to say their measures add up to be 180 degrees, right? And then we also said that we had isosceles trapezoids sometimes. So if the two legs are equal, then the base angles are equal. Let's add that information. Okay, there's two sets of base angles. I know these ones at the top are, they don't feel like base angles, but the ones at the top are also base angles. So the angles that are between the legs and along a base are called the base angles. And this would be an isosceles if the legs were equal to each other, right? So we may have put that notation on this trapezoid because the only tool that I have right down here is an isosceles trapezoid. Every time I make it a figure, I get an isosceles trapezoid. Now, I want you to notice, we're going to talk about kites in a second. This software program doesn't have the option to make a kite. So I had to go into GeoGebra and make one. I took a picture of our exploration. So let's go back and let's finish off our quiz. Okay, make sure we have everything taken care of in the quiz. So I was just saying that the mid segment is half of the two bases added together, right? So we go 1/2 of 14 plus 42. Those two add up to be 56, right? Half of 56 is 28. So this mid segment must be 28 long, right? All right. I hope I'm making that clear. I really need you guys to, be as mature as possible when you're doing your homework problems. Try to resist the temptation to just ask a neighbor for an answer because you just want to get it done and get it out of your hair. I get that feeling, but try to resist that. Try to ask me lots of questions on like how this stuff works so that you get these quizzes right. Okay, we're going to have an essay quiz on this concept, and it's going to be on the test as well. All right, let's talk about kites real quick. So in our little exploration yesterday, if everything would have worked perfectly, everyone would have seen a kite. Some people's widgets, if you will, were not working. And I wanted to show you, like the kites have two sides that are equal, two consecutive sides that are equal, and then two other consecutive sides that are equal. And that generates some pretty useful properties with the diagonals in particular. So since this widget didn't work so well, I made a sketch on GeoGebra, and I want you to notice that we have a 90-degree angle, right? That's kind of really, really critical for this problem. And that these two angles here that are between, let's see, how should we say this? Between the non-equal sides. So this side does not equal this one down here. I could get the measure. I probably should have done that. Let me do that real quick, okay? So if I want to measure the distance, right, I can just click on this guy. See how they're not equal to each other, the 9.8, 5.8, right? But the 5.8 over here and the 9.8 over here, see how they have two equal sides here and two equal sides there? That's what makes this a kite. So I need you to add that to your notes right now. You're going to add this drawing. And then let's mark up the angles that are definitely equal to each other. So this angle here is going to equal this angle right over here, right? And then I want you to put down a right angle symbol right there. So this right angle is going to allow us to use the Pythagorean theorem to find unknown side lengths, all right? That's kind of critical. Now, I want to show you just real quick, this is the last thing I want you to think about, is how did I make this drawing right here? I actually didn't start with two equal sides and then two other equal sides. What I did was I started with one diagonal, and then I constructed the midpoint or the perpendicular bisector. You could just make the perpendicular bisector. You don't really need to make the midpoint first. It'll find the midpoint for us. And then I just put 2 points on there. So like 2 points on the perpendicular bisector, and it didn't matter where I put them. And then I made the segment that would connect those 2 points to the endpoints of my segment. So we learned pretty early on, like, almost a month ago, that if you have the perpendicular bisector of a segment, any point on the perpendicular bisector is going to be equidistant to the two endpoints. So now if I go and I measure, again, let's see, where did the measure menu go? Right here. If I measure this side and this side, they should be equal to each other, right? And then this side here should be equal to this one over here. And if I just move these two around, it doesn't matter. You know, could I make it into a rhombus? You bet I could. I mean, I could make it just, 5.2 all around, right? But it doesn't have to be like that in a kite. Like, it could be like that. This is still a kite. The diagonals are always perpendicular to each other because you saw me construct it, right? You saw me make the perpendicular bisector of this segment. So how does that come into play in our homework? Well, we're going to review some together in class. I'm going to go over the one, let's see. Oh, before we move on, hold on one sec. I need you to get the back side of your worksheet done. Okay, so I want you to summarize a few things. How are the diagonals all related to each other? They're always perpendicular, right? And then are they always perpendicular? Yes, they are. And then you could say that the opposite angles, shoot, I wish I would have got that picture right there. Let's see if I can get that picture on the screen here real quick. That's like this picture right here. Let me put that over on the right side of the screen. All right, so I'm saying KJM. Let me see here. Give me a second. I'm going to say KJM has to equal, so KJM has to equal KLM, right? And that is the angles that are between the two unequal sides are congruent to each other. Now, we put that in our notes, right? So I want you to fill the worksheet out, and we're going to turn this worksheet back in because I said it's going to be an automatic homework assignment. So I hope I'm making that clear. I hope you have some good notes, and let's just review what kind of notes you have. And then we're going to take some questions in class on these problems here in maybe 10 minutes. So I hope that's okay. Let's maybe label this guy right over here, right? This is a kite. And this was our trapezoid over here. I got two trapezoids. So trapezoids are over here. All right. Thanks for watching my video, folks. Take care.